Hello again, this is Galen Pickett, Cal State University Long Beach, Physics 151. Today I want to talk about Section 13 of Chapter 3. And the problem I have in mind is this right angle traffic collision. So we've got two situations here, Situation A and Situation B. I've got a car going at the speed limit V0, and I've got a truck going at the speed limit V0. They collide at an intersection, they stick together, making an inelastic collision, and then they slide off in some direction V final. So that is the situation A. Situation B is I've got two cars, both the same masses. One's going the speed limit, but one's going twice the speed limit. And then they collide together at a stop sign and slide off in some direction. What I want to know is which of these wrecks has got the bigger V final. And you could think to yourself, well, let's make a quick analysis of this. I'll say there's an X direction, there's a Y direction. The initial momentum of the system for case A is I've got m times v0 in the x direction. That's the momentum of this first car, to which I can add the momentum of the truck, which is 2m. It has a mass of 2m, and it has, oh, sorry, that is not a vector symbol there. 2m times v0 going in the y direction. Now, since we're talking about a collision, the momentum principle will say that the final system momentum is equal to the initial system momentum, and I've got the two components here, so I can just write that as mv0, 2mv0, and 0. So there is the final system momentum for case A. And let's do the same analysis for case B. So the initial momentum is equal to mv0 x hat. I could also write that as mv0, 0, 0. This x hat is a shorthand for saying this vector which has a 1 in the first place and then two zeros. So this is just a scalar multiplication of x hat. But then, oh, sorry, that is not the entire momentum of the system. Let's take that out, because that's just the car. Now the speeding car has got a momentum of m times 2v0 in the y direction. So altogether, I still have these two vectors added together. There's the x component, there's the y component. That would be mv0, comma m times 2v0, 0. And because we have a collision here, there's the system boundary. The initial system momentum is equal to the final system momentum because there's no forces from the surroundings. And I get P final is equal to P initial, which is mv0, 2mv0, 0. So what we conclude is that for case A and for case B, I got the same momentum in the system. There's A's final momentum, and there's B's final momentum. So you could say to yourself, it's the same momentum, therefore the same velocity, but that would not be right. Because to know how fast this thing is going, the final momentum is equal to the total mass in the system, which is m plus 2m times v final. That's just saying what is the momentum of the system. Over here in case B, I have final momentum is equal to, like, the mass of the system is now different. There are two cars, 2m, not a car and a truck, times v final. So we have two systems that have the same momentum, but this one has more mass. So it's going slower. This is the one which has got, so case B is the one with v final is the biggest. And you can think about it this way. If on the 605 freeway there were a momentum limit of, now let's say a car maybe is 1,000 kilograms, and then we'll multiply that times 60 miles per hour. If you had a 1,000 kilogram car, it could go 60 miles an hour. That would be its momentum limit. So I've got a car, m equals 1,000 kilograms. Its v top would be 60 miles an hour. If I had a car carrier, so here is a flatbed, a bunch of cars on top of that, and here's the truck carrying it, and let's say that its mass is 10,000 kilograms. I still have its momentum limit is 1,000 kilograms times 60 miles per hour, and that is equal to its mass, this 10,000 kilograms, times its v top. So just divide both sides by this 10,000 kilograms. That cancels off. This leaves a factor of 10. We get v top for the car carry would be 6 miles per hour. So that what I'm emphasizing here is that there's a difference between momentum and velocity. These cases have got the same final momentum. This one has got a much bigger velocity.